For most of human history, we've wondered if there are planets beyond our solar system. It turns out there are. Almost every star, like our sun, has a planet around it. There are so many exoplanets that we've actually found 5,000 in the past 2 decades of observations. Most of these exoplanets, though, are so small and hard to see. So instead, we look at stars, which are much bigger and brighter. So most of the exoplanets we've found have been from looking at stars and inferring there's a small planet around it by little changes in the star's light. We do have one way to directly see planets themselves, though, known as direct imaging. This is a really hard thing to do, though. It's a very hard problem. It's like trying to see a tiny little firefly buzzing around the bright lights of Las Vegas from all the way here in Los Angeles. We can do this, though, with technology. The image on the screen here is an image of 4 real exoplanets, all bigger than Jupiter, around a star a little over 100 light years away. In order to take an image like this, we first need a really big telescope that can collect as much light as possible from that tiny faraway firefly. Then we block out the big Las Vegas lights, the light of the star the planet is around. In the image here, you can see the center where the star is missing. This only gets us so far, though. Some of the light from that bright star gets past our defenses and leaves pesky dots of light in our images called speckles that get in the way of us finding planets. The image here is not data straight from a telescope. It's data that's been processed, meaning we use statistics to subtract away those leftover speckles and find the planets beneath. And that's where I come in. So for part of my thesis work, I've been working on new ways to better get rid of speckles in our images and find fainter planets. Remember, the more speckles we clean up, the fainter the planets we can find, the more Earth-like planets we can find. This is an example of what current data processing algorithms can do. After, you can clearly see this ring, which is actually dust that's working on forming planets. Algorithms like this only use information about where speckles are in the image, though, and we know that speckles move with time, too. So I've been working on an upgraded algorithm that uses that extra information about how speckles change with time in order to do a better job removing them. Right now, with direct imaging, we've only found about 50 of the biggest exoplanets there are. But we want to find those fainter Earth-like exoplanets in order to someday search for alien life. Improving our technology, like with my upgraded speckle removing algorithm, is really our necessary next step towards finally answering that fundamental question, are we alone? Thank you.